recording. It says it's recording. Okay, very good. Fantastic. All right, so cross fingers. Internet for the internet to cooperate. All right. By the time you are dismissed for your lunch today, you should have experience by listening, looking at many aspects of the lesson today about this particular question. Mhm. Keep in mind, as we have done many times in the past, in every phenomenon or a situation or a scenario which we have used this word many times in the past. Let's start the word again for the last few times with the word phenomenon at timestamp 104. This is when I will start counting your participation points. Phenomenon. Put it in the chat room. Waiting. I will start typing the word phenomenon and then type it as well. Phenomenon. There you go. Add the word phenomenon. You can copy and paste with my permission as long as you know the word that you copied and pasted is phenomenon. Alright. Quite sophisticated word that not everybody will use in a typical conversation. We can say situation. Yes, but let's sound more professional. And let me say, educated. You are educated. You are in the process of finishing your education. Eventually, you will go to the higher education, high school. Okay. Go from one ladder to the next ladder, achieving your goal. Okay, now the phenomenon we're going to think about. Thank you for typing the word. If you haven't, please do so because I can't. Need not to be said. I will get this uh, second to the last. All right, second to the last participation points. Excellent. Here it is, a question that we want to think about. Please read with me as I read it aloud. But for the time being, could you put the word, okay, put the word tectonic plate in the room once again at timestamp 106. Tectonic plate. This time, put the two words together, tectonic and a plate. What kind of plate? Tectonic. For us to know it's not the plate we used to eat. Excellent, Maria, you did it. What about the rest? I'm waiting for your name to appear in the room. Excellent, tectonic plates. All right, we expect that you feel a bit comfortable using the word, and we had multiple lessons on this. Okay, let me read, and please read with me as well. How does the movement of the tectonic plates, which we have seen in our lesson in the past, thanks, Jasmine, that this plate moves because of the heat coming from the core, which is the inner part or layer of the planet Earth. We have used many models, including a duct tape. Internally, inside, this object represents the core, which is extremely hot. And I asked you yesterday if you remember what's the approximate temperature inside. Did you say 5,000? Tell me. Put it in the room. Did you say 5,000 degrees Celsius? Yes or no? Timestamp 108. Waiting. Waiting. What is it? Is it 5,000 degrees Celsius? Yes. I'm just checking your memory. At the same time, if you are He, important. That's the first thing. Make certain you are mentally present. You can be present in the computer, but you're doing something else. You know that. Ghosting, 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 ghosting. Okay, back on the drawing board, which we're going to use this yellow tray. All right, call it the drawing board. This is where I work with you. Right, keep this in mind. We're using model. Now, we know that the plates are on the crust. They're moving. Because of the heat coming from the core, the mantle moves in a sorry, circular fashion, causing the movement. And in terms of vocabulary, it's called the convection current. All right, you heard it from the video we saw. Now I'm saying it, but the most essential is its movement. The circular movement could cause anything above to move away, towards, or side by side. Today we're going to look at this movement. Particularly, we will think like a local, meaning to say we will not go any further than Iceland. We're just going to think of California, our very own state, where we are. That's the first thing that we are going to do. So we can go outside. All right, are you still with me, by the way? Type in the room. At times at 110. Excellent. I can see Christopher Denise. Lovely. Okay. Excellent. We're getting there. We're getting there. All right. So let me ask you, you should be able to see the yellow tray once again. Let me take this question. Keep in mind, this is what we want to really hammer down, meaning to say, find out an answer by looking at an evidence. Evidence or artifacts using the models I have for you to use. Do you remember? Yesterday I showed you books. How many books did I use yesterday in our lesson? At least in a simple demonstration. How many did I use? Yes, Carlos, thank you. Two. Yeah, we're going to use it again, but we are going to show its motion and how it will affect us what the question is asking us. The location and distance of cities. Alright? Salinas, for instance. San Francisco, another example. LA, a popular city in California where lots and lots of people go. Oh, they're open. Disneyland is open for Californians. Yeah, I think we're doing a good job. They're opening in the midst of the pandemic. Okay, let me show you. You can see the books. I got something. Hold on. Ah, it's just a map. Okay, I'm going to take these objects away from our site first. You don't want that? Okay, for the time being, these are the two books that we used yesterday. Could you tell me times the 112 if you can see the blue books in the yellow tray? Both of them, the whole area, including the two books, solidly. Okay, lovely. Excellent. Okay, meanwhile, I will check where they are. Excellent. But I ask you to please pin the screen where you see my hand waving. Okay, because I will be moving the screen away and towards me so you can see in a better perspective. Okay, we're going to imagine that these two books are tectonic plates. All right, they're two tectonic plates that we are going to use one tectonic and the other tectonic plate. And since we will be thinking of California only, we're going to think of the two plates where we can find California. Two plates can have this one state of California. So that's where we are. There are two tectonic plates where California is found. All right, let's start first with one. And then in this one, hold on, let me back up here. Okay, it's fine. So when I show you one of the plates, could you tell me what city do you see? Let me start first with one. This is a plate. Could you tell me what city do you see? I'm waiting at timestamp 114. Type the city. Okay, waiting. All right, if you snooze, you lose the opportunity. Remember, I'm counting your names as it appear. San Francisco, a city in by the bay with a golden gate, and it's an attraction. All right, people will say, "Oh, okay, go to San Francisco, oh, go to California, but don't forget to go to San Francisco and see the Golden Gate." So it's not actually gold; it's the red. All right, but it's an icon, something to see. Just like when you go to Peru, make certain you go to Machu Picchu. When you go to Egypt, make sure you don't leave Egypt without seeing the Pyramid of Egypt. Yeah. Or if you go to, let's say, Mexico, and you go down in the center, make certain you don't forget to see the pyramid. Something that you will say, been there, seen that. Alright, okay, San Francisco. San Francisco is on a tectonic plate, and the plate where San Francisco is called the North American plate. Could you type the word North American? Timestamp 116. Waiting. North American. You can include plate. Wait. There's more name appearing, but I don't see the names that I'm expecting to appear, such as Vincent, Carlos. There you go. And Christopher. And Andrea. And Jennifer. And Jasmine. And Jose. Okay. Jasmine, are you able to connect with your phone? Jasmine, are you still connected with your mobile? Okay. Just checking. Because I gave her permission to use her phone because the computer doesn't work. Yes! This and other nearby cities is on the tectonic plate called the North American plate. And you see an arrow pointing down. Alright, we're going to get to that eventually. You know, this will represent movement. When we put this together, we will see what direction does it move. Alright, by the way, how are you doing? Are you hanging in there? Are you getting my point at this time? I know it's not a good question, but I want to ask you that question. Are you hanging in there? Yes, make sure you do, because we're almost halfway through. We just look at the first plate. All right. Okay, let me check once again. Yeah. Next. Tell me what city do you see? This is the other plate. Tell me what city do you see? Waiting at timestamp 117. Waiting at timestamp LA? Yeah. In Southern California. A lot of people are heading down south, especially if they're up north. Enjoy Disneyland. Enjoy the warm beaches. We have beaches here, but it's pretty cold. But they're warmer than here, especially in the summer. Alright, okay now. As compared to the San Francisco city, this is on a different plate. Pacific. Or North American, sorry. Alright, because this one, I was about to say Pacific, because Together with Big Sur. Have you been to Big Sur? Oh, it's beautiful. Have you been to Big Sur? Big Sur. That's where all the marathon. Yeah, it's very close to us, past Carmel. Yeah, go there sometime in the summer. Together with Big Sur and San Diego, the Los Angeles is in what tectonic plate is Los Angeles located? Type in the room. Waiting at time some 119. Pacific plate, right? Do it now, please. Put the word Pacific plate. Two different cities on two different plates in our lesson, San Francisco and LA. There are many other cities, but let's look at one city only, or two cities, I would say. Okay, the one that is pretty common, that most of you or everyone maybe have been to, or at least heard about, because it's pretty famous. All right, okay, let's take a look in a more detailed manner. I'm going to put this flat on the table. All right. Okay. I'm meaning on the yellow tray. So let me make certain that the right orientation. Yes. Okay. So now this time you will see the two plates, the two tectonic plates, the North American and the Pacific side by side. All right. So please take a look. Could you tell me? Could you tell me the direction of the arrow? Are they the same direction or opposite? At timestamp 120. Okay, I know you're looking at this, but I want you to focus on the arrow. Tell me, are they the same direction or are they opposite? Yes, opposite. Okay, need not to be said. This goes that direction and this goes this direction. All right. Oh, tell us direction. We've used arrow quite a few times when we learn the chemical reaction. When we learn food chain and food web. This time we're using it again. Multi-purpose, isn't it? Showing the direction of the plate. Okay. Now, back to our question. We want to make to know if the plates move, which they do, because of the convection current or the movement of the mantle because of the heat in the core. What is the effect? What will it do to the location and possibly the distance between, let us say, Los Angeles and San Francisco? But wait, there's more years to happen, to finish. Millions of years before we actually see massive difference. Just like the formation of the Earth. Millions of years. Similar to the Pangea or the supercontinent. Scientists have speculated that at around 200 million years, okay, it has started to move apart. But they have been there for many, many, many years. I cannot tell you exactly when. Even scientists always do approximation. But according to the evidence they got, at 200 year, meaning of 200 years ago, so they started separating, all right, drifting apart. All right, are you still ready, by the way? Just checking. Type in the room. Make me certain I'm not talking to computer and only 3 people here. Make sure that I'm talking to everybody, including you there at home. Excellent. Okay. Now, let's look at the movement. Could you tell me, when I move it, the other one this way and the other one this way, because of the arrow, could you tell me what's going on with the two cities? Are they changing location? All right. And are they getting further or are they getting closer? All right, once again, you're going to look at the arrow. I'm going to move them up on an opposite manner and focus your attention to, in addition to the motion, keep your microphone muted as always, now unless you need to say something Put your hand up. Right? Okay. So let's please please take a look and take a listen. So here it is. So let us say, for example, the two plates move. And remember, you will see between the two books, there is a line that separates them. What do we call this two line? Anybody know? Let me see. Okay, let's call it fault. All right. I will type the word fault, and please type it as well. Fault. All right, everybody, please type the word fault. You say, oh, it's not my fault. But your brother, your little brother start crying. You say, oh, no, no, it's not my fault. Oh, that is not the way we're using the word fault. It's like, who made your brother just like cry? That's not the way. It's not my fault. Here we are thinking and talking about a connection between two plates that is very, very movable. In this case, they can move. Mhm. How I wish I had the crackers once again, because in a cracker there is like a section where you can actually cut it easily. Mhm. Hopefully you have noticed that. There's a saltine cracker, those square cracker when you cut. There's a little bit of a kind of like a perforation. When you cut it along the center, it will cut evenly. Kind of like a crack when you cut. That's where the cut will happen. All right, let's look at the fault. All right, now the movement happens in the fault. Let me show you. Okay, once again, tell me when I move this plate goes to that way, and this plate goes to this way. All right, because there's an arrow. So when this move, could you tell me what happened to the distance between LA and San Francisco? Here is San Francisco, and here is Los Angeles. When this moved this direction, what's happening to the distance between the two? Is it getting closer or farther? Let me do it again. When I move this plate this way, what happened to the distance between the two? Is it getting closer or getting farther? Waiting, waiting, waiting. Yes, Jasmine. Look at this again, Jasmine. Look, here's LA. I'm gonna original location, original. Let's start with original. No motion, and then I'm going to move. Look at the distance between the two cities. All right. Here's the two cities. Okay, when I move this, what happened to the distance? Closer, right. Another movement. Closer, right. Because it's going this direction and this direction. On the average, how long if you're coming from Salinas, if you're driving? Yes, you're right, Carlos, correct. If you're driving, how many hours would it take you to go to Disneyland? Those of you who have been there driving with your parents, how many hours will it take you to go to Disneyland? LA, I'm waiting. Based on your experience, how many hours would it take you? Say that again? About 7, right? Yeah, plus all those stops and stop and go when you go to Marquette, Kentucky, or whatnot. Yeah, it's about 7 to 6 or 7 hours. Especially, it depends on how you drive. Right, of course, so following the rules, 65, 70 miles per hour. All right. So now, if this will happen, which happens because the plate moves, we can say that many, many years from now, we're going to spend less gas in going to LA. Less gas because the distance become closer and closer and closer and closer, shorter and shorter and shorter. The drive time become lesser realistically. So it is speculated, meaning to say, based on what has been happening, scientists thought that these two major cities, millions of years from now, will be much closer. All right? And remember, this is the Pacific Ocean. This is going inland. Pacific Ocean going inland. So, what may happen to San Francisco? I don't know. Search it online. When you search online, they will say, will San Francisco be covered with water? Because it's by the bay. Right? There's many speculations or possibly theory. But I'm not gonna be scared about because it will take years to happen. Right? But remember, Earth is so dynamic. What did I say? What word did you hear me say? And I used this word in the past. I said dynamic. Put the word in the room. Dynamic. I'm waiting timestamp 130. Dynamic. Waiting, yeah. Meaning to say, it's always changing. I guess just like you, always changing. Especially if you are at your age, you are growing. At my age, I will no longer grow. I am turning 55 years old. I'll be retiring next year, so in your case, you're growing, right, on a regular basis. Your grade can even change. Yeah, I noticed that. I know that. Each time you participate and I enter the full 10 points, there's an improvement. Then, stop participating again. I went down again. It's all about consistency. Meaning to say, all the time. Just like the plate, they're moving all the time. Yeah, we don't feel it because we are too small compared to the plates. And have you heard of this? What do I have in my hand? I'm going to show it to you. And put it in the chat room. Okay. Have you seen the movie San Andreas Fault? Have you seen the movie? Yeah. Pretty amazing, isn't it? But it's a it's a science fiction though. It's still on Netflix. The San Andreas Fault. Today, when we finish the lesson, I will take you to a short documentary that you will be able to see. Aside from the movement, the change in the distance of some cities, according to what they said, we are going to see also the effect of movement of the plate, which is a natural catastrophe. Now, what do we experience in California? That they said it happened multiple times. What do we have? What is that natural phenomenon that's beyond our control? The movement. The earthquake. Correct. Good, Christopher. Yeah. We are in the fault line, and that fault line is called the San Andreas fault line. All right. Where is that? Let me take you back to the book. I'm taking this glasses because I have this mask is pressing my temple, and this one is pressing too, just to relax my side. Okay, where is this fault? Right there. That's the fault line, the one that connects the two. And as I said a while ago, this move, and this is called the San Andreas fault line. Okay, yeah. Apparently, this is the longest fault line in the world. It's about 800 miles. 800. How many miles? Tell me, how many miles is fault line? 800. That's a lot. Okay. From here to LA, it's about 350 miles. Yeah. It's only 350 miles. Yeah. 800 miles. You're gonna go from northern Oregon down south, down to Mexico. Okay. Yeah. Explore more if you wish. Go online, you have your computer. Yeah, yeah. So Earth is dynamic, it's always changing. Now, last but not the least, what do you think? Is it a good idea to live on the plate, to put a house on the, I'm sorry, not the plane. Is it a good idea to build up a home on a fault line? Is no, not at all, right? You'll say, oh, a very cheap house. That's on the fault line. Oh, very inexpensive. I don't pay to the nose. It's only, let's say, $50,000 and you have 7 bedrooms. Wait a minute. Where is it located? Oh, it's in the fault line. Or closer to, no, you don't want that. And here in the States, when you are hunting for a place and you build your home, and there are surveyors, there are engineers, architect, they will give you, oh, sir, madam, this is not a safe place because it's very close to the fault line, San Andreas Fault. Okay, now can you say, can you stand? Can you trek? Can you hike on a fault line? Yes, you can. You can. Kind of like sometimes you cannot even. Yes, you can. Yeah, sometimes you cannot even. Oh, it's a fault line. You can use sometimes just a hill. Yeah, I've been to several fault lines. In San Andreas, in Iceland. Yeah, Iceland is a volcanic nation. There's two fault lines as well. The North American fault. I'm sorry, the North American plate and the European plate. That's why Iceland is a country that is seated both on American as well as European, because Iceland is on the European plate and the North American plate. That's why some, oh, where's Iceland? Is it Europe? Well, depending who you ask. If you ask people from the North Americans, oh no, it's not, it's America. But if you ask people from the Europe side, they will say, oh, it's Europe. But technically, it's Europe. All right? How are you doing so far? How's your level of understanding? I've never asked you, and I'm asking you now. A 5, that's great. Excellent. What about the rest? I'm waiting. Level of understanding. Let me see. Yeah, 4, 5, good. It's okay with you 3? It's fine. All right, now have we accomplished our goal by answering the question? Have we? Waiting. Have we accomplished our goal? Did we answer the question? Let me see. Put my glasses back because I'm not blind by the can't see. Yes, I think so. We saw that when the two plates move this way, San Francisco and LA may possibly become closer geographically. But keep in mind, this will take millions of years, thousands to millions of years. Okay? I guess we're not here anymore. Yeah? Yeah, because I believe people die. There's a certain lifespan. So do your best. Do your best. Be your best. Enjoy your best. And be nice. It's the most important thing because we never know what may happen in the future with regards to natural catastrophe. We are very close to the San Andreas Fault, and California is prone to earthquakes. We don't have tornadoes, we don't have hurricane, unlike in the mid east like Kansas, or in the eastern part like Florida. They have the cyclone on a regular basis. Now they're entering cyclone season. We don't have cyclone here. I mean, cyclone is a massive storm. Whoa! Once in a while we have, but it's not something that we get on a regular basis. But we have earthquake. Have you experienced massive earthquake in the past? Massive as in really you will wake up and see everything is falling apart. You're in California at your age? Probably not. Have you? I had. Yeah, I had. At least to I have to get out of the building and shelter myself in a place where nothing is falling. Alright. Okay, class. I'm going to stop the recording and we're going to move on to the next step. And this time we're going to look at a catastrophic event, earthquake in California.